Welcome back to our series on the Fermi Paradox. The Drake's equation was the last episode.
Welcome back to part 2 of the Fermi series. Fermi Paradox was named after physicist Enrico Fermi.
Enrico Fermi was an Italian physicist, widely acclaimed in a lot of different fields of physics, both theoretical and experimental and theoretical, I should say. He is commonly regarded for his contributions to nuclear physics and the creation of the atomic bomb, which, as he would probably confirm himself, was not necessarily something to be proud of in every regard. But he's made a lot of very worthwhile contributions to science, and that is illustrated by the fact that there is actually a Wikipedia page called Things Named After Enrico Fermi, of which the Fermi Paradox is one, which we will be dedicating today's episode to. The paradox being the universe is gigantic. If life can form so easily, it should be extremely common. Why isn't the universe and the galaxy crawling with life? Why do we seem to be the only ones despite how much we've looked? Now, there's obviously quite a few explanations out of that problem, some more likely than others, which is what we'll be discussing today.
Okay, yeah, well, basically there's a billion stars in our galaxy that are similar to our sun, and many of which are billions of years older than the Earth, and why we have not seen other intelligent life surviving or thriving in space is unknown to us.
We're a very young species on the cosmic scale. We are complete idiots. We have no idea what we're doing. We are at any given point in human history on the verge of destroying ourselves, and we've only been listening for the past half century. We've only been actually performing complex astronomy for a very short time in human history, so we really haven't looked very far. We really haven't looked very much. Our technology is not particularly advanced, so there is a very good chance that the universe is crawling with life, but we're just stupid to realize.
Well, that's actually on an interesting note. I read recently, that we've been trying to contact aliens with radio waves.
As opposed to the uninteresting notes we keep posting?
No, but because they recently started using lasers to transmit data from past satellites, which is modern technology, but it might be that our technology is just not good enough to pick anything up because they might be using something far in advance of what we use.
Yep, or we're just listening in the wrong locations at the wrong time. I mean, SETI and most science projects are heavily underfunded, so we may have just missed a signal, or as you said, we're drowning in them, but we can't perceive them because we haven't figured out how yet.
Yeah, well, the problem with radio waves is even if we got a radio wave from a planet, by the time it got here, that planet might not even be there anymore.
For example, I mean, even if we keep it in our close proximity of the space we find ourselves in, we've only been listening for a couple of decades. So, hypothetically speaking, saying we find a signal tomorrow, if we answer, then chances are that when it reaches the original sender, they'll have wiped themselves out. And the same is true for us. If we're sending something out, which we have done, then chances are that by the time someone else receives it, we'll already be dead.
Or the case would be your technology would be so much more advanced that you get a signal, but you would never pick it up.
Well, you could, hypothetically speaking, but I mean, what's the point of sending out signals and listening if you're just abandoning previous technologies?
Well, they have done so with many certain types of radio telescope.
Well, yeah, but as far as I understand it, radio telescopes that were to follow were more capable of picking up even slighter radio signals and even fainter ones. So even if we were contacted with the same technology that we were using at the start, the more advanced technology that we would be using later on would be capable of also intercepting the signals of the earlier versions. I believe the first one was the Diana project in 1946, just basically a ping of a radio signal of a tolling bell aimed at the moon. But obviously, not just the moon was hit; the signal kept going, and who knows who's heard that signal by now.
Yeah, but there's the other thing. By the time a radio signal gets somewhere, it's just absorbed by background radiation of the universe.
Well, yeah, but if your technology is advanced enough, then you can probably make out the difference in the background radiation and an actual intentional signal. I mean, turn on your TV, look at the static, if you've got an old boxy one, and you're looking at a few percent of original background radiation and a lot of static from the stuff we're sending out.
Yeah, of course, people in the past have thought they've picked up signals from aliens, however, they turned out to be pulsars.
Well, we have had a couple of things that are unresolved as of recent discoveries. I mean, if you notice a major dipping in a star of a discovery that was made last year, I believe, we saw like a 20% dip in a star, which was too big for a conventional planet as we know it to have caused that. I mean, no gas giant at any distance would cause such a dip. So I mean, I'm not saying it's aliens, but it could be some sort of megastructure or a Dyson sphere or something. It's wishful thinking, but it's not very scientific, but it's fun.
Yeah, well, science fact comes from science fiction, so they say.
Well, yeah, the only difference that fiction and nonfiction have in common is that fiction has to be plausible.
Yes, I mean, imagine the technologies we have now compared to the past. They'd be amazed.
Just look back a couple hundred years and blow some minds with everyday technology we have right now.
Yeah, like the computer chip from was in 1970, and it's like 3 megabytes, and it's ginormous.
Yeah, well, as you probably know, NASA had less computer power in their entire organization when they put someone on the moon than anyone has in their pocket in their smartphone right now.
Yes.
Speaking of interesting recent discoveries, just a few weeks ago, a terrestrial-like planet was discovered among our very close neighboring star. The Alpha Centauri system is a triple star system, and the red dwarf star in that system, Proxima Centauri, actually has a terrestrial planet orbiting around it. Was found after several years of research. Similar size, similar chemical complexion, so it might be closer than we think.
Yeah, well, there's been found to be liquid water on it, but as any planetoid in a dwarf star system, one side of it would be continuously facing the sun, and the other side would be cool and dark.
Well, not every planet around a red dwarf has to necessarily be tidally locked, does it?
It does if it has liquid water on it due to the size of the star.
Is that the gravitational pull on it keeping the planet from orbiting itself?
Yeah. Same as Mercury around our star, but Mercury's distance is somewhat similar to what...
And it doesn't have liquid water.
Yeah, it doesn't, but it's around our star, which is about 80 times larger than Proxima Centauri.
I didn't know tidal locking was that fixed and that dependent based on the factors. I didn't even know any of that.
Ah, it's quite common. Our moon is also tidally locked.
Yes, or it just has a weird face on it. Hypotheses. You have to respect my opinion. I could be right.
Yeah, well, so if we went to that planet, it would be tidally locked on one side, which means the idea of night and day would be completely alien to them.
Well, perhaps, or you could have a night species on one side, a day species on the other side. A lot of interesting ideas.
It's an interesting thought experiment, especially if life is more common around red dwarf systems. We would be somewhat alien to the majority of species which evolve.
Well, there is a strong case to be made for most life and most advanced civilizations around red dwarf stars, simply because of how stable they are and how long they live. I mean, expected lifespans of much greater than the current age of the universe.
Yeah, that's true. But also, the other thing which has been thought experiment is around our star we have 2 large gas giants which deflect a lot of the asteroids which would hit Earth. But in a red dwarf system, you're far more likely to get hit by asteroids.
Well, there's always a trade-off, I guess.
Yeah, so they might live longer, but their extinctions might be far more common.
You know, if you live long enough to become advanced, be able to deflect that sort of thing, then who knows what else you could come up with to prevent that from happening.
Could move on to Europa.
Yeah, we still haven't even excluded the possibility of life in our own solar system.
Stuff like electricity would not work well underwater, which is our primary power source.
Well, actual industrialized electricity as we know it in our society would probably not be particularly practical. I mean, the whole worldview of a species inside a hypothetical civilization under the ice sheets of Europa, they don't have a sky to look up to. They just have ice sheets that their technology might not permit them to break through, even if they are intelligent. Anyway, looking at the grander scale of where life is likely to be, why we haven't found it yet, as mentioned in the previous episode, we've only been detecting the planets around other stars for a couple of decades. I mean, both you and I were alive when the first exoplanet was confirmed and discovered, and we're up to about 2,000 of them right now, and obviously most of those are gas giants because, well, they're bigger, so they're easier to detect. And only in more recent years are we actually finding some interesting leads on terrestrial-like planets. So it really, in that regard, seems as if we're just held back by our technology, and the more we advance, the more we're actually finding of how common it could potentially be. I mean, life is just another step in that equation.
Yeah, well, like the original Drake's equation, it was 50-50 whether there was actually rocky bodies around other stars. Now it seems more than likely that most stars have rocky bodies around them.
Yeah, when you look at the Fermi Paradox as a whole and you apply Drake's equation to it, then if you're just filling in the factors with better technology, and you can get that number a lot closer to reality, and that's the fact that we've only been managing to do that in the past 2 or 3 generations is pretty fucking interesting.
But so there's a massive leap in technology, like a new form of communications.
Well, yeah, you never know where the next interesting technology is going to come from. That what is the use of science? Someone asked Michael Faraday, and he replied, "Well, sir, what is the use of a baby?" I mean, when Einstein came up with general relativity, did he really think of lasers as, hey, we can use that to scan things at the supermarket?
Yeah, true. I mean, E equals mc squared was just part of a mathematics equation to do with gravity. It had no implication of nuclear weapon.
Which brings us back to Enrico Fermi, as he was one of the key architects in making a more practical application for that then theoretical scientific discovery.
Yeah, he was part of the movement towards peaceful nuclear.
Well, he was involved in the Manhattan Project as well, I believe.
Yeah, but also the whole 50s, trying to move nuclear from a giant weapon of destruction, which brings us back to the end of the world.
We seem to be drawing ever closer towards by very definition.
I think that humanity will survive, at least for another couple of thousand years at least.
Well, I'm gonna have to stop you there, because if you can just settle other star systems and you're safe from even a supernova by just moving your home system, if we make it off this planet, then it will be very difficult to wipe out our entire species.
And now I'd like to talk about AI and the probability of that overtaking us. As you probably know, most machines, when they're eventually programmed with sort of evolutionary programming, can evolve at an exponential rate compared to regular terrestrial life.
But if there is actual AI that develops an intellect that the usual doomsday scenario is based on, just basically a computer thinking on its own, a robot realizing, hey, my goals don't necessarily align with the goals of my creator, and just taking control and having the upper hand because it is the technology that the society it finds itself is based on, and just selectively committing genocide against its creators. That's the common scenario, which I don't find uncommon. And a lot of people with me, Elon Musk and Stephen Hawking, come to mind. It is a risk to be considered, but I'm not sure if at this point in time it is our most likely way for us to wipe ourselves or our civilization out.
No, true. But if a civilization lasted long enough, I mean, you have the Books of Dune where they say they outlawed AI for that reason. But if, hypothetically, humans don't seem to have any inkling to do that, we just seem to be trying to make machines smarter and better than us in every way. They're struggling, but they will eventually surpass us.
In several ways, yeah. I think a lot of the concern stems from our tendency to want to do better for the sake of doing better and just improving without really thinking of the long-term consequences, or just seeing positive consequences and being completely blind to the negatives.
Yeah, true. Like we discussed before, on separate occasion, about if tuning synapses are similar to computing power, then we are very, very close to being surpassed.
Well, in raw computing power, just mathematics, calculation, memory, we've been surpassed a very long time ago. When it actually comes to reasoning, problem solving, adapting one's behavior to changes, there's a lot of room for improvement, but I don't know if I'm sufficiently technologically literate to say how far we are from that, but I don't consider it wholeheartedly unlikely that I will live to see that day, and in turn, the end.
Well, the main problem has always become that computing power to the similar level of the human brain uses so much more energy.
Well, yeah, but if nature could do it in 4.5 billion years, just by random mutations and natural selection to weed out the things that don't work, then actual targeted development should be able to do it a whole lot faster. I mean, we all know the adult statistic of what replicating a human brain would be right now, a supercomputer the size of a housing block powered by a nuclear reactor. Well, we managed to do it in just 1,400 grams of meat inside a skull, chilled by brain fluids, powered by the equivalent of a 20-watt light bulb. Just a matter of efficiency. Enough development would probably see something rivaling that, or more likely far surpassing it. It's just a matter of time once you get to that point.
Yeah, well, I do wonder if machines will surpass us in our lifetimes anyway, which is probably, what, 20 2080, 2090 maybe?
I hear earlier estimates, but that's usually from the same group who predicted that we'd have a functioning Mars colony by the new millennium.
Which we could have technologically, but humans are so good at not doing something.
Yes, that we are. Well, looking at not just our own ways to wipe ourselves out, but other alternatives for the answer to the Fermi paradox of why there is no life, where statistically it should be. I mean, we are currently discussing the possibility of life's tendency to wipe itself out, but there are, of course, other explanations.
Well, yeah, well, maybe any sort of evolved intelligence doesn't last that long. I mean, even the human genome is relatively limited compared to other animals which live on this planet.
Well, that's one idea. I mean, there's also, of course, the idea that life is just not as common as we'd like it to be. I mean, even if it's so incredibly rare that it's one in hundreds of billions or one in trillions, and we might be the only life, not just in our galaxy, but in the 100 galaxies around us, then even if that were the statistics, then life would have still occurred around 1 billion years in the observable universe.
Yeah, but there's always the problem of the age of the universe, and that in the early stars, like older stars, the planets surrounding them don't have as complex materials in them. Like their elemental table would be very limited. Like iron in our blood comes from a star.
And earlier stars were, of course, generally speaking, bigger because there was simply a greater concentration of hydrogen, so they wouldn't have been as stable and lasted as long as, say, a yellow star like ours does, or a red dwarf would. But that also has the flip side, that despite those odds, if life had occurred earlier, the amazing head start they could have over us.
Yeah, true, but we might be the first, because our star is a third-generation star, if I remember correctly.
Well, yeah, I suppose the more complex your chemistry gets, the more variables there are that make it likely for life to arise. But I don't really see any reasoning for why a third generation would be the minimal prerequisite required for that. And not just talking about the arising of life, because if you're just talking life, then it's going to be more difficult to detect.
Yeah, but the main thing in the Fermi Paradox is where is everybody else? Even if there are other third-generation stars, and that's where life potentially would start, there should at least be some civilizations slightly more advanced than us.
Well, yeah, I mean, considering the age of the universe, even if they traverse the statistical barrier of not having the complex chemistry as abundant as we did when our third-generation star arose with the planets surrounding it, even if they surpass that hurdle, then they have a potential head start of billions of years. But that's overlooking one thing, because we're not just talking about life, we're also talking, if we want to consider how probable it is that we detect life, then as we've established, it is more probable to detect an advanced civilization than just rudimentary single-celled life or something of the sort. So that brings us to the question of, once you have life, how likely is it that it will advance into a technologically sophisticated civilization? Now, we touched on this a little bit in the Drake's equation, but I still think it's a worthwhile question to have, because it brings a very deciding factor into the very question of the Fermi paradox.
However, there's a very interesting thing, that if you were on a planet where humans are intelligent mainly due to the use of fire, so you're on a planet where fire doesn't burn at all, there's not enough oxygen or there's too much, even if you are oxygen-based carbon life forms, and then you can't make fire, so you can't cook meat, so you don't get as smart, and then you're sort of stuck in the ape-like evolutionary scale.
I think that might be a bit tunnel-visioned. I mean, that question seems to assume that our way of developing intelligence and becoming technologically advanced is the only way.
Yeah, but cooking is the primary way you get intelligence. I mean, it's a better way of getting calories quicker. I mean, surely other things would eat on other planets.
Well, it's one way, and it seems to be quite an efficient way, but we have a very narrow reference frame. We only have ourselves, and nature has a lot more creative ways of doing things than we could ever come up with. So I think we're going to be surprised on that front.
Perhaps, but chloroform-based life forms like plants are unlikely to become moving and intelligent because they don't need to.
Yeah, that's a good point.
Yeah, it's probably going to be some sort of animal. I mean, the probability, if you look on evolution on this planet, they're going to have eyes, they're going to have a head, they're going to have some sort of legs and arms, so they can manipulate things. If they don't, then they'd have no way of making technology.
Well, that's true for the mental capabilities and having some form of arm or finger to manipulate technology. I mean, I suppose a tentacle or something of the sort would also work. But going back to Europa, which we touched on earlier, I mean, if there is life on Europa and if there's advanced life on Europa, it's going to be deep underneath the ice sheets. Maybe there is some form of bioluminescence. But essentially speaking, it would stand to reason that light would not be a primary way of detecting your environment there. So you could be very intelligent, but you wouldn't have to waste a lot of brain power on processing visual signals, which would leave room for other things.
Yes, yeah, I mean it would, but even most deep sea creatures have some sort of eye.
Yeah, it requires a lot of devolution to lose your eyes. On Earth, it's very useful to have, but again, I'm not so sure that that's universal.
Yeah, but there are other sensory organs which you find on Earth, like seeing in the ultraviolets or infrared, which you find in snakes. So it stands to reason they would have some sort of sensory organ on their head.
Yes, well, there's several sensory organs, and most of ours are concentrated on our head because it's nice and high. It makes it easy to detect our environment. But on a planet that had no such abundance of light to detect our environment, or Europa, for example, I mean, touching on electricity and bioluminescence, it's not inconceivable that you'd have some electric field to detect what is around you. Would be a very useful tool for hunting. But if we purely look at the cosmological equivalent of it, the very statistics of the universe as we perceive it, then the very baselines for prerequisites of life as we understand it bring us back to the Drake's equation. And that reminds me of a study done by researchers of the Harvard-Smithsonian Center for Astrophysics in 2013, who, based on Kepler measurements, concluded that 17% of observed stars has an Earth-sized planet. Now, that may seem like a relatively low number, but I think that is a really interesting statistic because it stands to reason that with our early rudimentary technology, the most planets around other stars that we would detect would, as I mentioned earlier, be gas giants because of their sheer size, how easy they are to detect. So the fact that a relatively large number of 17% is a lot smaller than that, if we detect that with our rudimentary technology, it isn't inconceivable that that number is actually a lot higher, and we will find that out as our technology advances. I mean, if we look at our own solar system, using that as a limited frame of reference, the smaller planets outnumber the gas giants, correct me if I'm wrong. So who's to say that that's not typical, and that we will find that out as it becomes more possible to discover smaller objects around other stars, which, again, reminds me of the discovery of Proxima Centauri b just last week.
Yeah, well, I think that's I think we've covered all the bases here. So join us next time when we go into the Kardashev scale.